We have done our project on pneumonia detection. We have used deep learning techniques for our implementation. As pneumonia patients who have been detected positive has maximum chances to detect positive for COVID. So we have taken this project for as our minor project. As pneumonia is an infectious and deadly illness in respiratory that is caused by bacteria, fungi, or a pandemic that infects the human lung air scarce with the load filled with fluid or pus. With the emerging engineering development is an automatic system to detect pneumonia, and testing the disease is now possible, especially if the patient is in a very distant area or medical service. So the aim of our project is to determine whether a person suffers pneumonia or not. If yes, it determines whether it is caused by bacteria or virus. Our scope is to obtain significant characteristics in image classification tasks and provide medical promising results in image analysis. As pneumonia is an illness that disturbs the lung air scarce of an infected person, it is triggered by bacteria, fungi, or any infectious air scarce of lungs that stock up with discharge fluid that ends up in chills, fever, coughing, etc. We have used radiography, CT scan, or MRI images as our images in our project. The contribution of this study is developed an optimized deep learning model of CNN which will detect and classify pneumonia disease efficiently. So these are the papers we have referred for our projects. And our project has four modules. The first one is data collection and pre-processing. We have collected our data using Kaggle and the data has been processed, and we have trained our model using convolution neural network algorithm. The model has been tested with an accuracy of about 86%. And the next will be continued by our group mates.
This is the architecture diagram. And this is the data flow diagram. This is the use case diagram. And this is the sequence diagram. This is the activity diagram. So in testing, we have four: unit testing, integration testing, system testing, and functional testing. So in unit testing, it is a method for testing the software that looks at the smallest testable pieces of code called units, which are tested for correct operation. So the main task of unit testing is to detect the errors and elimination of bugs. So the next is integration testing. So the aim of integration testing is to test the interfaces between the modules and expose any defects that may arise when these components are integrated and need to interact with each other. And this is system testing. So in testing technique, where we check how the input data is changing without affecting the entire performance of the model. And the last one is functional testing. So in functional testing, it is performed using the functional specifications provided by the client and verifies the system against the functional requirements. So this is the input, and this is the output we got from the input. This is the conclusion. This research explores the deep learning function in detecting pneumonia through computer vision using convolutional neural network models. It is having an accuracy rate of 80%. So these is future enhancements. The phenomena infected diseases and normal chest X-ray image dataset are acquired from Cargill. Further research can continue to investigate to find better opportunities to imbalance issues for image datasets. These are the web references we have referred. And these are the references we have referred. These are the pages which we have referred. And this is our plagiarism report for PPT. And this is a poster presentation which we have made. And thank you.
This is our project demonstration video. Here we used Kaggle platform for deploying our model, deep learning model, which is pneumonia detection using deep learning techniques. Here we can see many, this is very large input, which is nearly about 2 GB data. Which is loaded into this. And here starting step is to import libraries. Here Matplotlib and Seaborn for data visualization, sklearn and Keras for module and evaluation matrices, CV2 for data processing, OS for accessing data directories, and NumPy and Panda for processing. And we go for the data pre-processing. Here we loaded images, which are our input images, norm images and label images. Two labels are created. And here we print loading images and process the input. We train the images model which used to detect. Here we print the trained data. Next we show the data, plot some random images, loading test images. Here label pre-processing, which we train and test the model. And we reshape the data because some of the data will be fuzzy and blurry. So we reshape the data and we augment with zoom range of 0.1 and white shift 0.1 and height shift also 0.1. And we print CNN for applying CNN algorithm for the model. We flatten the data and we calculate the loss and accuracy. We display accuracy by plot matplotlib and also confusion matrix here. Here we can see the output loading images. Here every input is loaded and displaying some random images of bacteria, normal and virus pneumonia. And again the data is reshaping, which is of 200, 201 in size. And in this model there are 30 approaches to validate the model. After loading 30 approaches, it displays the accuracy score, which is about nearly 0.8, that is 80% accuracy, and the loss is 0. Nearly 1. And finally it displays the confusion matrix, which looks like this. There are 3 elements in this: bacteria pneumonis, actual normal lung X-ray, and virus, which displayed here. Actually there are 229 more than 229 bacterial pneumonia cases. It correctly detected 229 bacterial pneumonia, and 229 bacterial pneumonia is detected in bacteria pneumonia. 15 images are detected as actual normal X-ray and 27 as virus pneumonia, that is actually some loss. And also same as in this normal predicted, actually there are more than 189 in actual images. It detected only 189 correctly, and 12 as bacterial pneumonia and 3 as viral pneumonia. And in same as well as in virus also, there are more than 118 viral pneumonia pictures, and it detected only 118 correctly, and 30 as the actual images, and 1 bacterial pneumonia. This is our final deployment. And we need to create a web page to display our to upload a one picture and get whether that particular image having is pneumonia or not. We are trying to install it. That's all. Thank you.